question from CBSE 2024-25 sample question paper published by CBSE Academics. Okay, it's a good question and will teach you at least one concept which a lot of students face difficulty in. So let's start this question and I will now present the question to you. Let's read it together and try to understand how to solve this. Okay. All right. Okay. Now the question says it's a series LCR circuit. The voltage across the resistance, capacitance and inductance is 10 volt. Okay. So it's a LCR circuit and we already are given the voltage etc. across each of the element. Okay. The capacitance is now short circuited. Now this part is something which student will find slightly complicated to understand, right? But let's understand what's happening. Okay, so let me just draw the circuit first. So I have this resistance, I have an inductor, and this is my capacitor. Okay, and this of course is an alternating current. This 10 volt is across each element. So VR is equal to 10, VL is equal to 10 and VC is equal to 10. So if I see the problem from the point of view of a phasor diagram, the phasor diagram tells me that this is my VR, the VL, right, is this, okay, and my VC is equal, on the downward direction. So we understand the concept of lag and lead, I believe, right? So this is 10 volts, this is 10 volts, and this too is 10 volts. Now we know if VL is equal to VC, right? They're out of phase. The circuit is resistive, which means Z is equal to R when VL is equal to VC. They're out of phase. And therefore anyway this circuit is only resistive. Okay, that hint is given. Okay, so which means it's a kind of resonance which is already happening. Okay, now let's talk about the next step. What's happening here? Okay, so now you are shorting the capacitor. So you short the capacitor. Shorting the capacitor means in a LCR series circuit all the current was passing through the elements was identical, right? In a series circuit the current is same here, the current is same here, and the current is same here. But now you have shorted the capacitor, which means you have given a path to current to bypass the capacitor. The key word is bypass. You have bypassed, right? So since you bypassed it, the current goes from this path, which is this path, and comes out like this. Now the circuit behaves in a manner that there is absolutely no capacitor in the circuit. So capacitor has been taken off and now the circuit looks like this. Okay, so let me just show you how the circuit looks like. The circuit now has been reduced to this. Okay, so this is 10 volts, this is, okay, so let's see. So there is no capacitor available to you now at all, right? Now the question is, what is the voltage across the inductor? Is it 10 by root 2, 10 root 2, 10 volt and 20? So if I were to draw a voltage triangle, and I were to say what is the magnitude of the voltage being supplied by this, right? What is the magnitude? If I know the value of VR, I know the value of VC and this, then the overall applied voltage will be given by VR square plus VL minus VC whole square. So I was applying a voltage of only 10 volts. Okay, so a 10 volt voltage was being applied because VC and VL have got cancelled from each other, right? So this is 10 volts we have to find the voltage across this. What is the total voltage available here? Okay. Now if you notice, this has become an RL circuit. In an RL circuit, the current will lag, right? Just a general remark that it will lag, right? So there is no doubt it will not lag. The question is, what is the overall voltage which is left on L? So let's think what exactly is happening. So if you have shorted this and now you're left with only R and L circuit, if you short this, then the voltage across the inductance will be how much? By shorting, you removed the capacitor, and now the total voltage which is available to you looks like this. VL has become 10 and VR is equal to 10. So you can see by shorting the circuit, in fact what is happening is you are providing a reactive component voltage to the inductor which is 10 volts only. So not a very difficult problem, but looks very tricky because I think generally when we do a lot of questions, right, the voltage of the capacitor and inductor is different. So finding the applied VRMS, right, which is the applied signal, comes off naturally. It comes like VR square plus VL minus VC by square. You can write VC minus VL square also, but here since they were equal, so therefore overall voltage available, right, from the was 10 volts RMS and appearing only as a dissipative component, which means the power is dissipated in the resistance. No, and shorting is the main key theme in this question. So when you short a capacitor, you're eliminating it from the circuit. So right, so which means its impact, this impact goes away, and you're only left with these two. So if you have to find this, what is a voltage now being supplied, it will be 10 square plus 10 square, which is VR square plus VL square is equal to 10 root 2. But that is not the question. It is only the voltage across inductance which has been asked. So I hope you like this question. Please go to my playlist of alternating current, a very important chapter for students. This chapter actually is closely related to the concepts of electrical engineering, and therefore it's important that you understand it. In fact, in medical science also you use alternating current, and therefore to create a strong foundation, don't forget to miss out on this chapter. I have more than 200 videos which are conceptual, help you do a lot of practice and retain the concepts. Also join my community where I'm putting the questions. It will help you immensely in improving your marks and score. So thank you very much and look forward to see you soon with my next video.